Hello, and welcome to today's NITC webinar, Racial Bias and Driving Yielding Behavior at Crosswalks. My name is Lisa Patterson, and I will be your moderator for today. I am the Tech Transfer and Workforce Development Program Manager for TREC, the Transportation Research and Education Center at Portland State University. TREC houses NITC, the National Institute for Transportation and Communities. NITC is the federally designated National University Transportation Center for Livable Communities and is a Portland State-led partnership with the University of Oregon, Oregon Institute of Technology, University of Utah, and our new partners, University of Arizona and University of Texas at Arlington. Our webinars are based on original research and conducted by faculty, researchers, and students at NITC partner universities. The goal of these webinars is to get useful research results into the hands of practitioners, academics, and other stakeholders. All right, our speaker today is Dr. Kimberly Barsamian-Kahn. Dr. Kahn is an associate professor of social psychology at Portland State University and leads the Gender, Race, and Sexual Prejudice GRASP Lab. She received her PhD in social psychology from the University of California, Los Angeles, with minors in sport psychology and quantitative psychology. She received her MA in social psychology from the University of California, Los Angeles, and her BA in psychology from the University of California, Berkeley. Dr. Kahn was a postdoctoral scholar at the Center for Social Research and Intervention at Lisbon University Institute in Lisbon, Portugal. Dr. Kahn's research addresses contemporary forms of subtle bias and prejudice. Specifically, she examines hidden forms of bias such as stereotype threat, phenotypic racial stereotypicality bias, masculinity threat, and implicit bias. Her work moves beyond studying broad categorical distinctions between groups to provide a more nuanced and fine-grained analysis of modern prejudice, stereotyping, and discrimination. Within transportation contexts, her research focuses on bias and intermodal interactions between drivers, pedestrians, and bicyclists. Before I hand it over to Dr. Kahn, I'd like to give you a brief overview of the webinar. Dr. Kahn will talk for about 40 minutes. During this time, you can submit questions, which will be answered at the end of the webinar. The webinar is being recorded and will be available on our website. Once the video is processed and uploaded, we will email you a link to the video and presentation slides. If you are tracking continuing education credits, please note that this webinar is eligible for 1 hour of continuing education credit. Instructions on how to redeem the credit will also be included in your post-webinar email. We also have a couple upcoming webinars. On November 9th, Joanna Ganning will be presenting What Do We Know About Location Affordability in U.S. Shrinking Cities? And we also are co-hosting a webinar in partnership with Landuse Consulting and FHWA on October 30th, featuring Alan Greenberg with FHWA, James Coey, ICF Strategic Consulting, and Sonika Sethi from Landuse Consulting on transportation benefits of parking cash out, pre-tax commuter benefits, and parking surtaxes. All right, and so during the presentation, you may submit questions for Dr. Kahn by using the questions pane on your control panel. We will track questions, and Dr. Kahn will respond to them at the end of the webinar. If we run out of time, we'll make sure that written responses go out for any questions left unanswered. And with that, I will hand it over to Dr. Kahn to talk about her research.
All right. Let me get this. All right. Thank you so much for that introduction, and thank you everyone for joining me today to talk about a series of studies in our projects on racial bias and driver yielding behavior at crosswalks. So, getting my slides ready. Okay. As was mentioned, I am an associate professor of social psychology at Portland State, and this project then came as a collaboration between myself, my graduate student, which is Jean McMahon, and two now assistant professors in transportation. So we were able to really merge the social psychology aspects of prejudice and bias, which is my area of expertise, within a transportation context with Tara Goddard and Dr. Kahn and Adkins, who are both assistant professors in transportation. um, to look at this intersection of social psychology within transportation and intermodal conflict. So just some background as we get started when we think about pedestrians' experiences at crosswalks. So we know that pedestrians are most vulnerable when they're crossing the street, and pedestrian deaths often occur during these street crossings. So this is really an important safety concern. When we look at the data then on pedestrian deaths at crosswalks, racial minorities are overrepresented in general in pedestrian fatalities. When we look at the rates, the fatality rates for Black and Hispanic men, for example, they're about twice the rate that it is for white men. And this is even when we're controlling for things like higher traffic exposure in urban areas, differences in socioeconomic status, or individual factors like alcohol use. We still see that this disparity exists. So one potential reason for this disparity might be in the different treatment that racial minorities pedestrians experience when they're trying to cross the street. So we wanted to try to unpack these interactions, which really led to our research study. Are drivers' yielding behaviors being influenced by a pedestrian's race, which then would result in different experiences for racial minority pedestrians that could ultimately affect their safety? So again, here we see that merging of both the psychology of bias with transportation contexts. So there has been some work that's been done looking at drivers' treatment of pedestrians, and what you see is that drivers do not treat all pedestrians the same. We know that drivers' yielding behavior is influenced by the demographic characteristics of both the pedestrian and the driver. So when we think about both sides of that intermodal interaction. One study, for example, found that drivers of high status cars are less likely to yield to pedestrians than those with lower status cars. We also see some preference where drivers are more likely to yield to people who are in their same age group, an in-group preference. And we also see that drivers are more likely to yield to disabled individuals compared to others. So when we see this differential yielding based on these identity characteristics, we have the question, what about race? Would race also be something that's influencing drivers' yielding behaviors? And we initially started studying this topic with our prior NITC grant, where we tested whether pedestrian race influenced driver stopping behaviors in an experiment with Black and white male pedestrians. This was done in 2013, and we conducted a controlled field experiment in which we had Black and white male pedestrians wait to cross the street at a marked crosswalk in Portland, Oregon. And I'm going to go into more details about the field experiment and the setup behind that, because it was very similar to what I'll be talking about as the current project. But doing this controlled field experiment, what we saw is that when we coded the driver's behavior of their behavior towards the Black and white male pedestrians, we found the predicted racial bias in drivers' behavior. So we found that Black male pedestrians were passed by about twice as many cars as our white male pedestrians, and on average they waited about 32% longer at the crosswalk until they had a car yield for them compared to our white male pedestrians. So this was a smaller, initially pilot study to see if this effect was there, and we did see some strong evidence that Black male pedestrians were being treated differently than our white male pedestrians. When we started to unpack what was going on there, we think that we drew on social psychological theory of prejudice and bias, and that this differential treatment of pedestrians might be due to what we call implicit racial bias. Implicit biases are subtle, biased beliefs that individuals hold beneath their conscious awareness. So this is different than what we think of as our explicit, conscious, or traditional attitudes. This instead is a second form of attitudes that is less conscious but reflects these implicit associations that we hold about and beliefs about different groups. So even though these are beneath our conscious awareness, they can still impact our behavior in ways that, again, we're not aware of. And we know that implicit bias then, because it's based at this implicit, less conscious, associative level, is pervasive across society. So we see that a large percentage of Americans actually hold some level of anti-Black implicit attitudes. And these can, again, be a cause of discriminatory behaviors. So when we think about the driving conditions as drivers are encountering pedestrians, we see that these conditions are very conducive for implicit bias to potentially impact individuals' behaviors. So driving is a fast-paced situation. There's a lot of distractions going on. People have to make very quick decisions to stop or not stop for a pedestrian. And there's some discretion also involved. There's ambiguity. People have latitude in their behavior. So all of these types of situational attributes make it more likely that these implicit, quick associations are going to influence behavior. And so we think that could be one of the reasons we're seeing this type of bias. So this then, based on these initial findings, we then extended this research in the current projects that I'll be talking about by examining how pedestrian race along with gender interact to influence drivers' yielding behavior. So we wanted to both replicate and extend this basic effect that we found. So what I'll be talking about today is a series of controlled field experiments that we conducted that were based on the prior study but had some important additions. So as I mentioned, in addition to race, we also examined gender. So we included female pedestrians. And we were really interested in the interaction of race and gender. Do we see the same treatment for Black men compared to Black women? Or do we see that there's differences based on these race and gender interactions? Next, we also examined whether the presence of a marked crosswalk, so a crosswalk with traditional zebra stripes, regulatory and advisory signs, and a stop bar, influenced driver stopping behavior differently than when the crosswalk or when the intersection is unmarked. And I'll go into more about that differentiation. But do we see that there's differences in these stopping behaviors based on race and gender when there's more infrastructure there compared to when there's less infrastructure? And finally, we also wanted to test whether drivers' identities, so the driver characteristics, drivers' own race and gender, influence their stopping decisions. Now, there's some social psychological theories of prejudice, for example, that suggest that white males tend to direct more prejudice and discrimination at racial minority males. So we might see an interaction there with those two identities, which might imply that our white male drivers may be least likely to stop for Black male pedestrians, for example. But alternatively, we might find that these stopping decisions really occur across driver race and gender identities, which would again suggest this more implicit bias and a more pervasive problem. So in addition to those controlled field experiments, we wanted to complement that quantitative study by looking at some qualitative data as well. So what we did was then conduct 3 focus groups with African Americans to probe and understand their experiences as pedestrians in crosswalks in Portland. And so this would allow them to describe their personal experiences crossing the street, how they feel they're treated by drivers, and if they feel there's any impact of their race in these interactions. And so I'll be sharing some of the findings from that as well. So I'll start by talking about our series of field experiments, and the 2 that we ran have a similar setup. So I'll go over the basic design of that, and then we'll get into the specifics for each of the phases. So the benefits of doing an experimental design is that we're able to isolate factors and assess causality. And by doing this in a natural setting, we can see how in the real world drivers are interacting with pedestrians of different races and genders, but we're able to control for various factors that allow us to assess causality in the role that race and gender is impacting their behavior. So the experiment then was run twice at the same location. So we took advantage of a natural change that was happening with more infrastructure being put in Portland. So we first ran the study when the crosswalk or the intersection where the pedestrians were crossing was unmarked. And I'll go into, again, more specifics about that. And then approximately 9 months later, we ran another field experiment at that same location following the installation of the crosswalk, which consisted of the zebra stripes, some crosswalk signage, and a car stop bar. So we took advantage of that natural change to look at those differences. And then we had trained coders in the field during these studies that recorded the outcomes of the crossing trials. And I'll get into the specifics of what the data collected looked like. So the location of this study for the field experiment for this series of studies was in Southeast 14th Avenue and Southeast Belmont Street in Portland, Oregon. This is a 2-lane, one-way street that has pretty consistent car and pedestrian traffic. It's near single-family homes and small businesses. It's a well-maintained business district and neighborhood that's near downtown Portland. So it's a place where there's consistent car traffic. Pedestrians would be crossing in this area, and it's a lively district and area as well. The specific crosswalk and intersection that we studied then was about 2 blocks downstream from an intersection with traffic lights. And so the traffic light downstream then meant that there was a new fleet of cars that were passing approximately, once every 3 to 4 minutes. And so we were able to take advantage of that timing there as well. Now, as I mentioned, during phase 1 of the experiment, which was in September 2015, the intersection where the pedestrians were crossing was unmarked. Now, in Oregon, all intersections, even if they're unmarked, are legal crosswalks, and drivers are supposed to yield for pedestrians. So they're still a legal, valid place to cross. In April then 2016, the City of Portland then actually installed the crosswalk at this location. And so this included those zebra stripes on the pavement, signage that directed drivers to stop for pedestrians ahead, and a stop bar that was marked on the pavement. And I'll show you a picture of what this looks like in a second. The stop bar then was marked on the pavement about 10 feet or so before the intersection, indicating where cars should stop to allow the pedestrians to cross the street. Then phase 2 of the study, when we reran that field experiment, occurred about 2 months after the installation of the new crosswalk. And this then allowed drivers time to sort of grow familiar with that design change, and so the novelty of it would be reduced in our data collection. So here's a picture of the location again with the installation of the crosswalk. So you can see the sign and the stop bars closest to us in the picture, indicating where cars are supposed to stop, and you can see then the zebra stripes and the actual crosswalk where the pedestrians were crossing. So for each of the 2 phases of the experiment, we had 12 people that we recruited to serve as pedestrians in the study. So this was ended up as a total of 24 pedestrians. And these were included then for each phase: 3 black men, 3 white men, 3 black women, and 3 white women. They were all residents of Portland, and they were all young adults. The age ranged from about 18 to 30 years old. And even though there's some variability there in their ages, drivers would all view them as similarly aged when they were quickly encountering them at crosswalks. The average age was about 24 years old. All of the study pedestrians were prototypical in appearance, and what we mean by that is that they were easily identified as their correct race and gender. They also all had an average build. They had no visible tattoos or facial piercings. And during then data collection, we standardized the appearance of all of the study pedestrians as much as we could. So we did that by having them wear identical plain gray t-shirts that were provided for them. So they wore the gray t-shirts along with blue denim jeans and pants. They all had their hair down. They had no visible jewelry. And so we tried to make this appearance as neutral as possible and as similar as possible across the pedestrians to be able to control for these confounding factors, so that any differences we're seeing in treatment can be explained by pedestrian race and gender rather than some of these other characteristics. And we also trained the pedestrians in the crossing procedure, which I'll discuss in a second. So they all approached the crosswalk in the same way, and we standardized that crossing experience as well. So phase 1 of the study took place over 2 weeks in September 2015. Phase 2, as I mentioned, was in June 2016. All of the trials then that took place were in the afternoon between 2 p.m. and 5 p.m. and we did this to avoid traffic congestion that would restrict free flow conditions. So anytime as if there was traffic that led the street to be constricted, that ended our experiment. So each individual pedestrian crossing was considered a trial. The trial would begin when a member of the research team would signal the start of each trial, which was when the first car after that traffic light that was about 2 blocks downstream would change, and the first car would cross a marked starting point that we had identified that was about 200 feet upstream of the study crosswalk. So when the traffic light would change, the first set of cars would start to approach. When they hit about 200 feet upstream of the crosswalk, that would signal the beginning of the trial. So once signaled, then that individual study pedestrian would approach the edge of the crosswalk. They would stand at the edge of the curb, so they were not in the street. We were trying to protect our pedestrians. They would be at the edge of the curb. They would position their body towards oncoming traffic, and they would look at the oncoming cars directly to indicate their intent to cross the street. The trial then ended and our timing stopped when one of two things happened. Either a car clearly yielded and stopped, that allowed the pedestrian to then enter the street and safely cross, or the entire platoon of cars that were at that stoplight passed the pedestrian without stopping, and so then that next platoon was already stopped at the upstream stoplight. That ended the trial without any cars stopping. So once the trial ended, the pedestrian crossed the street and passed out of sight before returning to the crosswalk for their next trial. The next then pedestrian would be queued once the prior pedestrian had crossed the street and was no longer visible. The pedestrians were given a randomized order to cross the street, so we would first have a white male cross, then a white female, for example, then a black male, a black female, so though that crossing order was randomized. Any trials in which there were non-study pedestrians or bicyclists, for example, that joined the study pedestrian at the crosswalk, we continued those trials, but we then excluded them from final analyses. So when we're looking at the data, it's only trials in which the designated study pedestrians were alone, were the only ones that were at the crosswalk. And we conducted all of the trials when conditions were mild and clear. If there was rain, we suspended trials and only resumed when weather had cleared up. So the data that we then recorded, we had 5 members of the research team that coded the trials of the driver's behavior for each of the pedestrian trials. And they were positioned in the field in an inconspicuous place, either by a nearby restaurant or a bus stop, but places where they had clear sight lines to the intersection and that they would not be visible to the passing cars and drivers. And the data that was recorded for each of the trials were the following. So first we had the first car stop, and this is whether the first car to reach the crosswalk stopped for the pedestrian. And so this was recorded as a simple yes or no. Then if a car did stop, so if there was a car that stopped on that trial, we counted the number of cars that passed that pedestrian before a car stopped. We then looked at the trial length in seconds, so just the amount of time for the pedestrian to be able to cross the street. And so this was the timing beginning when the pedestrian was signaled to approach the crosswalk curb and ended when the car had clearly yielded and the pedestrian was able to step into the crosswalk, or again, the entire fleet of cars had passed. We also looked at the driver characteristics of the car that stopped. So if a car did stop for the pedestrian, we recorded the race as white, non-white, or unknown if possible, and gender, male, female, or unknown of the driver who stopped to let the pedestrian pass. And in phase 2 only, when again we had the marked crosswalk and the additional infrastructure, we coded the stop bar, the positioning of the car relative to the stop bar. And this was coded as before or after. So a car that stopped before the stop bar is obeying the signage and leaving the pedestrian a wide berth to cross. Now, if a car stopped after the stop bar, then they were stopping closer to the pedestrian and infringing on the crossing space. And so this is, again, is relative to the stop bar, so it's not necessarily that the car was in the crosswalk. It's possible that they still could have stopped after the stop bar, but still not been in the crosswalk. But instead, it's a measure of how close or how far back the cars are stopping, and whether or not they were following the designated sign, which is telling the cars to stop before the stop bar. So in phase 1 of the study then, at our unmarked crosswalk, our unmarked intersection, we ran a total of 330 trials. 11 ended up being eliminated because we had either a bike or a non-study pedestrian join the trial. And you can see the breakdown between the different groups of the trials. So in 60 out of the 319 trials, one of the cars from the entire passing platoon stopped for the pedestrian. So that's about 18% of trials was there a car that actually stopped. So that means in the vast majority of trials, no driver yielded to the pedestrian who was waiting to cross. And so as we'll see, this really low overall stop rate can limit potentially the effects of pedestrian race and gender on drivers' behavior because it establishes a floor effect. If we don't see cars stopping for anyone, we might not see those same differences. So what does the data look like here? So when we look at now whether the first car to reach the pedestrian stopped, we can see that there was an extremely low first car stopping rate. So I had said it was about 18% of trials where any cars had yielded to the pedestrian. It was about 2.8% now of times where the first car to reach the pedestrian actually stopped and yielded. So this was a very, very low stopping rate. We ran an overall chi-square effect test to see if there was any differences by pedestrian race and gender. And we did see an overall significant omnibus effect, but none of the simple effects were significantly different from each other. So we do see a slight pattern that white men were slightly more likely to have that first car stop compared to the other groups, but the overall low first stop rates really should be taken into consideration when we're looking at this data. When we look at then the cars that passed, so here again we're looking at the 60 trials of the 319 where a car did stop. Did we see a difference there based on pedestrian race and gender? And so we ran a 2x2 ANOVA to look at whether there was any significant differences in the number of cars that passed the pedestrian before when yielded. And again, we see a pattern and a trend where black men may have had more cars passing, but that overall ANOVA was not significant. Similarly, we don't see any significant differences when we look at trial length, so how long the pedestrians were waiting at that unmarked crosswalk. So we don't see a difference there. And finally, when we look at the driver characteristics of the car that stopped, so again, it was not logistically possible to code the race and gender of all of the drivers that passed the pedestrians. So we only have this information about the one that eventually stopped. But because pedestrians were randomly ordered, drivers should be equally likely to encounter pedestrians for all groups. So if we see that drivers are stopping for pedestrians disproportionately for one type of pedestrian than another, it suggests that they might have a preference for one group over the other. However, when we looked at the analysis of this, of the 60 drivers that stopped, we don't see any significant differences based on driver gender or driver race. They did not predict which pedestrian groups were yielded to. Again, we have a very low sample here, particularly with race, and so those that should be taken into consideration as we interpret these results. So our phase 1 conclusions, overall there was non-significant findings from phase 1 at the unmarked crosswalk. That's indicating that drivers didn't differentiate between black and white men and women at the unmarked crosswalk. So each gender and race group then had similar experiences as they were attempting to cross the street. However, this should be interpreted in light of the overall low stopping rates of trials in which any car yielded in the whole platoon of cars. Remember, we had about 18% of times where any car even yielded, and when we looked at that first car stopping, that was only less than 3% of the time. So what we see here is that while Oregon law says that any intersection is a crosswalk, the vast majority of drivers didn't yield to the waiting pedestrian at the marked intersection, despite their waiting on the curb with indications of wanting to cross. So in phase 2, now we ran the field experiment again after the installation of the crosswalk. So here we had 12 new steady pedestrians, again 3 from each race and gender group, similar age range, and they were going to cross that intersection that had received the newly marked crosswalk. As before, pedestrians were all young adults, similar age, similar build, clearly identified as members of their race and gender. However, we did have some participant attrition during this study that ended up being that only one black female completed the trials. So we want to make sure we acknowledge that in our interpretations as well. This time we had 485 trials at the marked crosswalk, and here we saw 76 trials eliminated with non-study individuals joining the crossing trial. So we can see already that that infrastructure is leading more people to join and want to use that crosswalk. Here when we look at the total of those remaining trials, now a car yielded on 396 of them, so about 97% of the time one car in that platoon did yield. So what does the data then look like? When we look at whether or not the first car stopped, here we saw that the first car stopped for the pedestrian about 55% of the time. So this is a large increase from our prior study where it was at 2.8. So we see a large increase in yielding behavior at this same location once that crosswalk was marked. When we look at differences with race and gender, the overall chi-square test was marginally significant, and then when we break down the simple effects, we see that white pedestrians were more likely to have the first car stop for them than black pedestrians, and we also see that female pedestrians were more likely to have the first car stop for them than male pedestrians. So we see those two differences emerge. When we look at then the number of cars that have passed, a car yielded here again almost 97% of the time at the marked crosswalk. And we found a marginally significant interaction here between pedestrian gender and race. And here the difference really was that black men were more likely to be passed by cars, particularly compared to black women. When we look at trial length, in a 2x2 ANOVA then, we don't see any significant differences in how long the pedestrians were waiting based on race and gender. Driver characteristics. Here again, we looked at the driver characteristics of the 396 drivers who did stop for a pedestrian. And as in before, we don't see any differences based on driver gender and driver race in predicting which pedestrian groups were yielding to. So we see that that didn't influence their decisions to yield. But again, we have low numbers, particularly with race, and so we want to interpret that with caution. The stop bar then that we were able to add and look at in phase 2, again, the stop bar is meant to provide ample space for pedestrians to cross safely. So we ran a chi-square test to see if that positioning of the car differed based on pedestrian race and gender. And here we saw a very significant chi-square test. So when the pedestrian was a black male, the cars were more likely to stop after the bar, so to stop closer to the pedestrian, to stop closer to the pedestrian. And similarly, when the pedestrian was a black female, the cars were also more likely to stop after the stop bar than before it. And we see the opposite pattern with our white pedestrians. The cars were more likely to stop behind the bar for our white men and white women rather than after it. So they were stopping further back from the pedestrians. So in other words, the stop bar's intended function of creating more space between cars and pedestrians worked most often when the pedestrians were white, but not when they were black. That the cars were crowding the pedestrians and stopping closer to our black pedestrians. So our conclusions then from phase 2. The marked crosswalk then led to increased stopping for pedestrians. We saw a huge increase in the overall stopping rates, but ironically it then led to less equitable treatment. So our marked crosswalk succeeded in persuading cars to eventually stop for nearly all pedestrians. So on almost all of the trials, at least one of the cars stopped. However, it did so differentially depending on their race and gender. So we didn't see significant differences in the time that pedestrians waited to cross the street, but we did see differences on whether the first car stopped, the number of cars that passed before one yielded, and the positioning of the car that stopped relative to the stop bar. Our white and female pedestrians were more likely to have the first car stop for them, while our black and male pedestrians were more likely not to have that car stop for them. Black men in particular were also more likely to have more cars pass them before one stopped. And further, when they did stop, drivers were more likely to stop with their vehicle behind the bar to give more space when the pedestrian was white, but after the bar when the pedestrian was black. And so this is an intrusion into the crossing space for black pedestrians and a possible safety risk. So we can see then that these series of field experiments provide some causal evidence of race and gender disparities at crosswalks. And this pattern then is consistent with implicit bias, as I had talked about earlier. One of the important things to note is the role of driver discretion in producing this difference. So even though the majority of trials included one driver yielding, still it was only that first car stopping at about 55% of the time. So drivers still felt that they had discretion in whether or not they needed to stop. And it's this discretion that is potentially causing that difference in treatment. So because of time, I'm going to skip over focus groups. And I'm happy to share this information with anyone that's interested. But we did see some very consistent findings and reports about people's interaction, the African Americans' interactions with drivers that were perceived to be affected by their race. I'll give just one example quote here. Of one of our African American focus group participants. I'll come to an intersection on one side and waiting because there's cars, and then as soon as a white person steps on the other side, oh, a car stops. I'm like, this is magic, what's going on? It was you, it wasn't me. So this is something that is very salient to our African American pedestrians and experiences that they could articulate. So the overall recommendations that I will leave you guys with is that marking crosswalks, then while they can be effective in increasing overall stopping, they can also bring about unequitable treatment depending on pedestrians' race and gender. So while we think that one way to potentially reduce this disparity and provide more equitable treatment is to reduce this perceived discretion in stopping behavior. By reducing that discretion, we might see more increased stopping rates for all of our pedestrians. And so this means we have to go beyond just the basic crosswalk design, where we might need additional signage, flashing lights, other infrastructure that would help reduce that perceived discretion and make drivers feel like it's more mandatory to stop for all pedestrians, and that might help reduce some of those differences. We can also think about media campaigns and awareness in actually highlighting this type of issue and promoting yielding for pedestrians, for all types of pedestrians at intersections. And I think that these studies also make a big point to consider the equity impact in planning. If we just looked at overall stopping rates, for example, after the installation of the crosswalk, that would appear that the infrastructure change was highly beneficial, but you would miss the disparity that's actually going on based on pedestrian race and gender. And so we want to consider equity in all of the infrastructure changes that we make. So I want to leave time for questions, and I'm going to stop there. Thank you guys very much for listening, and I'm happy to talk more about the focus groups or any of that data. There's my contact information here, and any interest in collaborating on future studies or more information about this study, I'm happy to share. Thank you.
Great. Thank you so much, Dr. Kahn. For those viewing the webinar, please feel free to continue to submit your questions. We do have a few questions already queued up, so I'll start with those. All right, so there's a couple questions on the case study that you had did. Did you additionally look at changes in yielding between the type of marking for crosswalks, or do you think the type of crosswalks would make a difference, for example, between transverse lines, continental, ladder, etc.?
Yeah, I think that that's really important, and I think that's where the next sort of steps on this go in this line of research. So again, we only looked at no infrastructure, so just an intersection with no signs, and that the one type of crosswalk that included the zebra crossing, the stop bar with also the sign saying, you know, stop here for pedestrians. But so at that sort of more common type of crosswalk, that's where we see these disparities. I think what we need to do now is to test really on some of these other types of crosswalk designs or infrastructures where there's the flashing lights that are alerting cars that there's a crosswalk and a pedestrian rating. Whether that type of additional infrastructure and signage can increase even the overall stopping rates, and then by doing that, reducing then the differences that we see depending on the type of pedestrian. So all of those other types of crosswalk designs, I think that's where we need to study now to see if one of those is more effective compared to the traditional crosswalk designs that we see.
Great. Was there any discussion on how this site is a one-way street, hypothesizing that one-way streets might cause drivers to act more speedingly?
Yeah, that's a great question. So we chose a one-way street for our pedestrian safety, that we could only have to keep track of one set of cars to allow them to cross. We might see, if we looked at a two-way street, that cars are driving more cautiously. If it's really because of these implicit types of biases that are going on, we think that there'd be similar patterns. We think that the driving characteristics and situations are similar depending on a one-way street versus a two-way street, and we might see some similar patterns. But that's, again, another future direction. There's a lot of additional things that we'd love to study with this set of studies. The benefits of the field experiment is that we can isolate a couple variables at a time to see what the effects of that are, but it means that we have to try to control those other ones. But certainly looking at a one-way street versus a two-way street, do we see similar patterns there would be important future work.
Great. Do you think that something about land use context and the actual site selected to test this experiment may be unique? I wonder how results could vary if a higher sampling of crossing locations were selected, i.e., yeah.
Yep, sure.
No, that's fine. I was just going to say in minority neighborhoods versus central business districts or suburban areas.
Absolutely. So we certainly think that the surrounding neighborhoods, land use, the demographics of those areas might be impacting this. Our first study that we did where we first found these effects was in downtown Portland. Here again, we were out into a neighborhood area that had a business district associated with it, and we see again some similar results there. But it would also be important to look at this in different neighborhoods with different types of infrastructure, with different types of demographics. Again, if we think that implicit biases are what could be directing these types of behaviors, those are pervasive across contexts and across individuals. So we might still see some types of patterns or bias there, but again, something that we want to look at.
Mm-hmm. Yeah, I think similarly, to build on that question, there was another person that was wondering similarly if you were to do this study in a community that was more diverse or that has historically been more diverse. For example, in the Williams Avenue locally, where communities, there is a history of racial tension.
Yeah, so that's again one of the things we're hoping to do next is to look in particular areas that have a history of more diversity within Portland, and also a history of different types of racial bias and attitudes. What we might see there again is a similar type pattern. We might see that strengthened depending on history of racial tensions in particular communities. There it might be a little bit more influenced by people's explicit attitudes. But again, because we're thinking about these types of decisions as really quick decisions where there's lots of stimuli going on, it's more likely going to reflect some of these implicit types of biases. It's certainly possible that as drivers are going by, they're consciously thinking about seeing and processing pedestrians and saying, no, I'm not going to stop for this group versus this group. But we just think that it's more likely that because of all the stimuli going on, people are making quick decisions, and that's where these implicit biases, these quick associations, are more likely to just sort of direct that behavior. So that would be a little bit less influenced by those neighborhood contexts. But a very important question, something we want to look at.
Mm-hmm. Great. And One more question, not to belabor this, but are similar studies being conducted in other parts of the country or world? And what are the differences that you have seen from those studies or expect to see in a more diverse city?
Great. So far there's only been one study that we're aware of that has replicated our this type of design and experiment, and that was done in Las Vegas. And they ended up having, I believe, only one black female pedestrian and one white female pedestrian. So it was a smaller scale done in Las Vegas, and they did see differences there in driver yielding, particularly when the black female pedestrian stepped into the street, into the crosswalk. In, I think, higher income neighborhoods, we saw that their data saw that cars were more likely to pass them and not stop. So that's the first replication that we've seen of this. This is, again, some newer research, and we really hope that other research teams can start looking at this in their own context as well. One of our partners is at the University of Arizona, so we're hoping to be able to look at this in Arizona as well. And then our other partner, Dr. Tara Goddard, is in Texas, and so that's another potential location that we're interested in examining these biases.
Great. All right, another question for future experiments. Can you see other races besides black and white being included? And is there a way to maybe include socioeconomic factors? For example, you had mentioned that people seemed less polite when driving high-value, expensive cars. Is there a way to create a class or perception for the pedestrians?
Absolutely. And I'll just put up some of our, let me see if, there we go, some of our future directions, which are kind of getting at a lot of these same questions. So if we wanted to look at other races, other non-black minority groups, absolutely, particularly thinking about Latino and Asian American individuals, we want to see, does the same bias extend to those groups, or do we see it stronger maybe against African American or black individuals? Absolutely think that socioeconomic status could play a role in this as well. We would have to think about, from an experimental context, how to operationalize that. One thing we could do is have our pedestrians wear different types of clothing. So we could have, say, a business suit, for example, compared to something clothing that is more neutral, or sweatpants or something like that, where we might be able to have our pedestrians actually change that clothing and look at differences there. So certainly ways that we could try to make explicit socioeconomic differences as well. And that, of course, would most likely interact with race, with the neighborhood locations, with the crosswalk designs, and you can see how all of these variables might play into each other.
Yeah, that's great. A lot of definitely future work to be done in this area. All right, I think we have time for one more question, and this goes back to the field studies that you had conducted, and specifically to the stop bar location. So the stop bar in this case seems unusually wide compared to the typical zebra striped crosswalks in their city. If the car stopped after the bar but before the zebra stripe, doesn't that mean that they still yielded, just not at the correct location? So the bias is not necessarily stopping but giving less space to the African American pedestrians.
Yes, exactly. So because the stop bar was a little bit further back, so they vary in certainly their locations. We've seen some stop bars being closer and some being further back. That it's possible that the car could have stopped before actually, infringing in the crosswalk. So they still yielded, but they were still closer to the pedestrian and still infringing in that overall space from where they were supposed to stop with the stop bar. So yes, it does not mean that they actually entered the crosswalk. We weren't able to code that in this study. That's something we actually want to look at in the future, is if they actually stop into the crosswalk. But they were still not giving as much space, as much sort of courtesy, and as the signs are telling them to do. So it doesn't necessarily mean that they were in the crosswalk, but they were still crowding them. They were still closer to them compared to our white pedestrians. And we'd love to be able to actually measure exactly how far cars are standing, and we have some ideas on stopping. We have some ideas on ways to do that. The stop bar being a marked, having a marked spot on the pavement is a really easy way to be able to see if they're obeying the sign, and be able to code non-conspicuously.
Great. Well, thank you again so much. This concludes our webinar. Thank you everyone for joining us today, and thank you again, Dr. Kahn, for sharing your work. You can view our other professional development offerings on our website at nitc.trek.pdx.edu. All right, thanks everyone. Enjoy the rest of your day.
Thank you.